Today we're talking about rates of change of polar functions. Let's remind ourselves how to find the average rate of change of a function in the Cartesian coordinate system. What is the average rate of change of f of x on the interval -2 to 5? Well, average rate of change, where's my highlighter? Average rate of change is our old Algebra 1 slope. Average rate of change is slope. y2 minus y1 over x2 minus x1, rise over run, delta f over delta x, however you want to think of that, that is average rate of change. Okay? F of 5 minus f of -2 divided by 5 minus -2. So we're going to go off to the side. Okay, we're going to find f of 5 and we're going to find f of -2. F of 5 minus 3 is 2, and 2 squared is 4, minus 2 is 2. F of -2. -2 minus 3 is -5. -5 squared is 25. Minus 2 is 23. So coming back, this is equal to f of 5 is 2 minus f of -2 is 23. 5 minus -2 is 7. So this is 2 minus 23 is -21 over 7. That is -3. So -3 is the average rate of change. It is the slope. It's the slope between the 2 points on the curve, on this parabola. Okay, to find the average rate of change of a polar function, we do the same thing. We just have thetas instead of x's. All right? So if I give you a polar function and ask you for the average rate of change, we're finding change in g over change in theta. Okay? And so this is still going to be g of 4 pi over 3 minus g of pi over 3 divided by 4 pi over 3 minus pi over 3. I'm once again going to go off to the side and find g of 4 pi over 3 and g of pi over 3. Okay, g of 4 pi over 3 is going to be 6 times cosine of 4 pi over 3. Cosine of 4 pi over 3 is -1/2. That's going to be -3 minus 5, so that is -8. G of pi over 3. 6 times cosine of pi over 3 is 1/2 minus 5. That is 3 minus 5, which is -2. Coming back to our average rate of change, we have the average rate of change is g of 4 pi over 3 is -8, g of pi over 3 is -2. 4 pi over 3 minus pi over 3 is 3 pi over 3, which is pi. So this turns out to be -6 over pi. That is the average rate of change of g with respect to theta on this interval. In the above problem, if g had units of centimeters, if the radius had units of centimeters, what would be the units of the average rate of change? Well, delta g over delta theta has units of g divided by units of theta. So that would be centimeters over, what are the units of theta? Radians. Or we write that as centimeters per radian. Okay? I'm getting very messy. This is what, the fourth video that I've made here within a couple of hours, so I can tell my handwriting gets messy when I have done too many videos at once. But here I am. Alrighty. We can use the average rate of change of a function to approximate a function value. Okay? Given that f is a continuous function with selected values given in the table, use the average rate of change of f on the interval -3 to 2. That should be a -2. Sorry, need to fix that for your notes. To approximate the value of f of -2.5. So we're using the average rate of change to approximate this value. Okay? So first we're going to find the average rate of change, delta f over delta x. Well, they tell me the interval to use. So f of -2 minus f of -3 divided by -2 minus -3. F of -2 from the table, f of -2 is -1. F of -3 is 5. -2 minus -3 is 1. So this is just -6. So the slope between those 2 points is a -6. So to approximate this value that we have no idea what it is, it's not in the table, we have no idea what it is, to approximate its value we can use the slope. So think of it this way. When x is -3, we're at 5. When x is -2, we're at -1. The slope between that is -6, right? We can approximate the value of when x is -2.5. It's going to be in between there, right? That's what we're doing. We're approximating the value, the f value of when x is -2.5. So here's how we do that. F of, what am I looking for? I'm looking for f of -2.5. I'm going to start at my lower point. I'm going to start at my lower x value point. So I'm starting at this point. I'm starting when x is -3. If I add the average rate of change, by my change in x from these two. This is the change in x. This is the change in x from -3 to -2.5. The change in x from -3 to -2.5 is a positive 0.5, right? It's -2.5 minus -3. And that will be a it will be a positive 0.5. Okay? I will get f of I put an equal to sign. That should not be an equal to sign. This is just an approximation. So I'm going to put approximately equal to. Okay? F of -3 is 5. So I have that -6 times the, my goodness, I'm messing up here. I should just stop. I can tell I should have stopped. I've just done too many videos. I'm messing up. All right, I'm going to keep going and see how it goes. I might end up deleting this. We will see. Okay. So I'm going to get, this is 5 minus 6 times 0.5 is 3, so this is 2. So f of -2.5 is approximately 2. I want you to take a closer look at this equation. Let me get a different color here. I want you to take a closer look at this equation. Okay. This is y at negative 2.5 and y at negative 3, right? This is like y2 minus y1. If I bring this over, that's like y2 minus y1 is equal to, this was the average rate of change, right? And average rate of change is slope. That's slope, true? So that's slope times change in x, x2 minus x1. We're just using the point slope form here. That's all this is point slope form. Okay? y2 is approximately equal to y1 plus the slope times your change in x. Okay? Why approximately? Because this m did not come from these two x values. It came from two other x values. It came from two other x values that we're using to approximate. If we knew the slope, this would not be approximate. It would be an equal to. Okay? Let's do another one. Let's do it with polars, because we're in polars. All right, let h be this polar function defined by this. Approximate the value of h of 5 pi over 12 using the average rate of change of h on the interval from pi over 3 to pi over 2. Okay? So I'm going to start by finding the average rate of change of h. Change in h over change in theta. They tell me the interval to use for that. So h of pi over 2 minus h of pi over 3 divided by pi over 2 minus pi over 3. Okay, so I'm going to go off to the side and find h of pi over 2 and h of pi over 3. Well, h of pi over 2, if I put pi over 2 in place of theta, I'll have 2 plus cosine of pi over 2. Cosine of pi over 2 is 0, so h of pi over 2 is 2. H of pi over 3. Well, h of pi over 3, if we put pi over 3 in place of theta, we'll have 2 plus cosine of pi over 3 is a half. 2 plus a half is 2.5, or 5 halves. I prefer to work with fractions mostly, so I'm going to leave that as a 5 halves. All right, back to our average rate of change. We have the average rate of change of h is equal to h of pi over 2 is 2 minus h of pi over 3 is 5 halves divided by pi over 2 minus pi over 3. Common denominator is 6. This would be a 3 pi over 6 minus 2 pi over 6. 3 pi over 6 minus 2 pi over 6 is pi over 6. Okay? So 2 minus 5 halves is negative 1 half. How do you divide by a fraction? To divide by a fraction, you multiply by its reciprocal, right? So this will be negative 3 over pi when we reduce. Negative 3 over pi is the average rate of change. Now we're going to approximate the value, okay? So think of it this way. Think of our old function notation. y2 minus y1 is equal to the slope times x2 minus x1, okay? Only we're in polars and we're approximating. So no equal to, instead of equal to, approximately equal to. And I go ahead and move that y value over, okay? Now, we want 5 pi over 12. I'm going to start at pi over 3. Pi over 3 is going to be my x1 in this situation. My x1 will be pi over 3. My x2 will be 5 pi over 12. I'm no longer using the pi over 2. So h at 5 pi over 12 is approximately equal to h at pi over 3 plus the average rate of change that we just found from pi over 3 to pi over 2 times my change in theta. Change in theta. Change in theta between my new theta values. So 5 pi over 12 minus pi over 3. Okay? So h of 5 pi over 12 is approximately equal to h of pi over 3, which we found up here, was 5/2. What is 5 pi over 12 minus pi over 12? Well, common denominator will be a 12. Okay, I need to multiply by a 4 over 4, right? 5 pi over 12 minus 4 pi over 12 is 1 pi over 12. So this is 5/2 minus, the pi's reduce out, 3 and 12 reduce to 1 over 4. So this is 5/2 minus 1/4. 5/2 is 10 over 4. 10 over 4 minus 1 over 4 is 9 over 4. So h of 5 pi over 12 is approximately equal to 9 over 4. Okay, I'm going to pull out my calculator because I want you to see something. What is the actual? I know the approximated value that we got, 9 over 4. What's the actual if we actually put 5 pi over 12 in place of theta? What will we get? We would get 2 plus cosine of 5 pi over 12. Look how close that is to 9 over 4. 9 over 4 is 2.25. Look how close it is. Not a bad approximation using the average rate of change. Okay, let's do another one. This table gives values of a polar function for selected values of theta. If the value of f of pi over 12 is estimated using the average rate of change, so we're estimating this thing using the average rate of change of f from 0 to pi over 6, which of the following is true? And it's talking about overestimate and underestimate. So the first thing we're going to do is actually find this approximation, this estimate. I want to find that estimate using the average rate of change. So step 1, average rate of change. So I'm going to come over here. I'm going to find the average rate of change. So I'm finding delta f over delta theta, average rate of change. F of pi over 6 minus f of 0 over pi over 6 minus 0. F of pi over 6, I can get that straight from the table. I don't have to go and figure it out. It's just right there. F of 0 is 1/4 divided by pi over 6. Common denominator. 1/4 is 2/8. 7/8 minus 2/8 is 5/8 divided by pi over 6. So the average rate of change is 5/8 times 6 over pi. We can reduce this, take a 2 out of each, and we get 3 and 4. So this is 15 over 4 pi. The average rate of change is 15 over 4 pi. I'm going to take that and use it to approximate f of pi over 12. You might be saying, why are we approximating it? It's right there in the table. Because of the question. Because they told me to. They told me to estimate it. They told me to find the error, essentially. So I'm going to because they told me to. A lot of times we just do it because they tell us to. All right, so f of pi over 12 is approximately equal to my starting value is going to be f of 0. Now I need to use my slope, which is the 15 over 4 pi, times my change in theta. Change in theta. Well, this is an easy change in theta because I have a 0 right there. Pi over 12 minus 0 is pi over 12. No fuss or fanfare for that one, right? So f of pi over 12 is approximately equal to f of 0 is a fourth plus, okay, let's reduce this. The pi's reduce out. 15 and 12 both have a 3 in them, so 4 and 5. So this is 5 over 16. And 1/4 plus 5 over 16. 1/4 is 4 over 16. 4 over 16 plus 5 over 16 is 9 over 16. So I found my approximation. So f of pi over 12 is approximately equal to 9 over 16. But from the table, f of pi over 12 is equal to 1/2. So is this an overestimate or an underestimate? Well, 8 over 16 is a half. So 9 over 16 is 1/16 higher. It's an overestimate by 1 over 16. Okay. Okay. Now let's talk about relative extrema. Relative extrema. Where are we at on time? Okay, we're doing good. Relative extrema. Well, to talk relative extrema, let's go back and talk about what we did when it was just regular Cartesian coordinates. XY plane. If this is the graph of G in the XY plane, how many relative maxima does G have? Well, G has a relative max here, and here, and here. That's a relative max. So there are 3 of them. How many relative minima does G have? G has a relative minimum there, and there, and there. So 3 of those as well. Since we're here, it's worth asking, how many points of inflection does G have? Well, a point of inflection is where concavity changes from concave up to down or concave down to up, from like a cup to like a frown, or from like a frown to like a cup. So somewhere probably around here, somewhere probably around here, around here, around here, and around here. 5 points of inflection. A nice little review from like way back in Unit 1 in August. For polar curves. For polar curves, how do you find a relative extrema? Well, if the function changes, if r changes, when I say the function, since the function is r, think, if r changes from increasing to decreasing, then you have a relative max. And that corresponds to a point relatively farthest from the origin, within some value of theta, containing that theta value. If r changes from decreasing to increasing, then you have a relative min. and that corresponds to a point relatively closest to the origin, possibly going through the origin within some interval of theta containing A. So, using that definition, let's mark on this graph the points where G has a relative max. A relative max. So, relatively farthest from the origin. Here, 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 and here. Visually, that's a relative max on a polar curve. Okay? Let's find them now. Let's find the theta values, determine all of the values of theta between 0 and 2 pi, at which the graph of r is equal to f of theta has a relative maximum. And there's f of theta. All right. Well, I know what the graph of this looks like. I know that the graph of this is a rose with 8 petals. Each petal has length 6. And since it's a sine, none of those petals are on the x and y axis. So if I were going to graph this, it would look something like that. I'm missing a petal. I'll go squeeze it in there. Okay. 8 petals, right? Something like that. We were not asked to graph it. The relative maximum and minimum are going to be all of these values. All of those. We want those theta values. Those theta values. Okay? Now, if this was multiple choice, in class I might ask students to brainstorm ways to find those theta values without doing a lick of like actual computation. But we're not in class, we're on a video, so I'm going to do this the way we're supposed to do it. Okay, I know that the relative maximum, each relative max occurs when we're out here at the tip. Where we're out here when we are at r is equal to 6. So I'm going to take my function, my 6 sine of 4 theta, and I'm going to set it equal to 6 because that's this will, if I solve this equation, it will give me the theta values that I desire, that form a relative max. Divide both sides by 6 and we get sine of 4 theta is equal to 1, which means that 4 theta, my argument, is equal to, I'm going to find 1. I'm going to find 1 and then I'm going to use symmetry to get the rest. What angle makes sine 1? That's pi over 2. That's one of them. There are more of them, but that's one of them. So theta is equal to, if we divide both sides by 4, theta is equal to pi over 8. So this first theta value right here is theta is equal to pi over 8. Now I'm going to use symmetry to get the rest. Okay? Use symmetry to get the rest. This is pi over 8 less than pi over 2, right? Or it is pi over 4 plus, it's pi over 8 plus pi over 4, either way. Each of these is pi over 4 units away from each other. It has to have the symmetry. So if I add pi over 4, I'm going to get 3 pi over 8. That has to be 3 pi over 8. If I add another pi over 4, 5 pi over 8. 7 pi over 8, 9 pi over 8 will be this one right here. 11 pi over 8, 13 pi over 8, and this last one is 15 pi over 8. Those are the theta values at which we have a relative max. Okay, one last little example. Which of the following is false? If r is positive and increasing, then the distance from a point on F and the origin is increasing. Think about that. If r is positive and increasing, what's happening to the distance? It is also increasing. If r is positive but decreasing, if r is positive but decreasing, then the distance between a point on F and the origin is also decreasing. Is that true or false? If we're decreasing, if r is positive and decreasing, yes, we are getting closer to the origin. The distance is decreasing. If r is negative and increasing, if r is negative and increasing, that means r is negative but getting less negative. So it's like starting at, I'm thinking of theta being in the first quadrant, but if r is negative, we're going to be down here in the third. We're going to land in the third quadrant even though theta is over here in the first quadrant, because r is negative. If r is negative but getting less negative, it's getting closer to the origin. So the distance is not increasing. The distance is decreasing. If r is negative and getting more negative, then the distance will be increasing. So the answer there is C. Okay, that's it for rates of change of polar functions. Rates of change of polar functions.